Look at the sky. Right now, above your head, space is quiet, dark, empty. But on certain nights, the sky explodes into color. Green waves, purple ribbons, red curtains of light, moving, dancing, breathing across the darkness. They look peaceful, almost magical. But here's the truth most people never hear. The northern lights are born from violence. What if I told you the most beautiful lights on Earth are caused by something that could destroy our entire civilization? These lights don't come from Earth. They come from the sun 93 million miles away. And every time you see the northern lights, it means Earth was just hit by a storm from space. So why don't we feel it? Why doesn't it burn the planet? And why do only some people get to see this cosmic warning in the sky? Let's break it down. What are the northern lights really? The northern lights, also known as the Aurora Borealis, are massive displays of light that appear in the sky near Earth's polar regions. They are not physical objects. You can't touch them, hold them, or capture them. They exist only for moments at a time, constantly shifting and dissolving. What you're seeing is not a thing, but a process, energy made visible. A brief moment when invisible forces collide and reveal themselves to the human eye. To ancient civilizations, these lights were spirits, gods, or messages from the heavens. Today, we know better, but the reality is no less astonishing. The northern lights are proof that our planet is not isolated. They are evidence that Earth is in constant conversation with space itself. So now comes the next question. Who causes the northern lights? The answer is the sun. The sun is not a calm, gentle ball of light quietly warming the Earth. It is a massive nuclear furnace, more than 1 million times larger than our planet, where unimaginable amounts of energy are released every second. Deep within its core, atoms are being fused together, producing constant explosions of power that ripple outward into space. Every second, the sun releases a stream of charged particles, electrons and protons, known as the solar wind. This invisible wind flows outward in all directions, filling the solar system and passing through planets as if they weren't even there. Most of the time, this solar wind brushes past Earth without consequence. But sometimes the sun snaps. Huge eruptions, called solar flares and coronal mass ejections, blast billions of charged particles into space at millions of kilometers per hour. These eruptions are among the most powerful events in the solar system. When one of them is aimed directly at Earth, those particles race across the vast emptiness of space and arrive in just 1 to 3 days. So where do they go when they finally reach us? They slam into Earth's magnetic field. Earth is wrapped in an invisible magnetic shield called the Magnetosphere. This shield is generated deep inside our planet, where molten iron moves within Earth's core, creating a powerful magnetic field that stretches far into space. It acts like a protective bubble, deflecting most of the sun's charged particles and shielding the atmosphere and everything living beneath it from direct harm. But this magnetic shield isn't perfect. It has weak points. At the north and south poles, Earth's magnetic field lines curve downward and funnel inward, creating open pathways into the upper atmosphere. When solar particles reach Earth, they don't strike randomly. They are guided along these magnetic lines, spiraling towards the poles at incredible speeds. That's why the northern lights appear in specific places on Earth, regions like Norway, Iceland, Alaska, Canada, and northern Scandinavia. These areas sit directly beneath Earth's magnetic funnels, where space energy is allowed to enter safely. Now comes the most important question. How does this create light? As those charged particles spiral downward into Earth's upper atmosphere, they collide with atoms of oxygen and nitrogen high above the planet's surface. These collisions transfer enormous amounts of energy. The atoms absorb this energy and become excited, unstable, overloaded with power they didn't have before. And atoms hate being unstable. So when they calm down, they release that excess energy in the only way they can, as light. Oxygen atoms produce green light, which is why green is the most common color seen in auroras. At higher altitudes, oxygen can glow red, creating deep crimson streaks across the sky. Nitrogen atoms produce blue and purple hues, adding complexity and depth to the light show. The sky is not reflecting light, it is glowing. Earth is taking dangerous energy from space and safely releasing it into the atmosphere, transforming potential destruction into breathtaking beauty. So when does this happen? Auroras appear mostly at night, when the sky is dark enough for their faint glow to be visible. They become more frequent during periods of increased solar activity, which follow an approximately 11-year solar cycle. During the peak of this cycle, the sun becomes more unstable, launching stronger and more frequent storms towards Earth. During especially powerful solar events, the northern lights can stretch far beyond the polar regions, appearing in places that rarely see them at all. For a brief time, the boundary between Earth and space becomes visible to millions of people. Now comes the question everyone asks: why don't the northern lights hurt us? Because Earth's magnetic field is doing its job. Without this magnetic shield, charged particles from the sun would slam directly into the atmosphere, slowly stripping it away. Scientists believe this is exactly what happened to Mars. When Mars lost its magnetic field billions of years ago, the solar wind gradually peeled away its atmosphere, leaving the planet cold, dry, and lifeless. The northern lights are proof that Earth is still protected. But there is a darker side to this beauty. The same solar storms that create auroras can also disrupt satellites, knock out GPS systems, interfere with radio communication, and overload electrical grids. In 1989, a powerful solar storm caused a massive blackout in Quebec, leaving millions of people without power, all while brilliant auroras danced silently overhead. So why do we love something that is technically a warning sign? Because it's rare, because it's beautiful, and because it reminds us that Earth is alive. The northern lights are a conversation between the sun and our planet, a visible reminder that Earth is constantly interacting with the universe around it, shielded but never completely untouched. So the next time you see the northern lights stretching across the night sky, remember this: you are not just watching a light show, you are watching Earth survive space.